what we are going to cover today is like what is a design pattern, and then we go over like what is a visitor design pattern, and then we look at a example of polymorphism implementation and a visitor design implementation of a same problem. And then we see when is it appropriate to apply visitor design pattern. There are some heuristics like when is a good candidate for applying a visitor design pattern. So let's get started. So what is a design pattern? Design pattern are like kind of a blueprint to common problems in software designs, and they are general solution you can apply to them, apply to your problems. Okay, and then you have to do some modification according to your problem because your problem is too specific to your requirement. But these are general patterns, blueprints which you can follow. Okay, and visitor design pattern in particular is a behavioral design pattern. So what is a behavioral design pattern? Behavioral design pattern like where we have algorithm and we have a data. Okay, so we want to apply the algorithm on the data, but the algorithm and data are separate. Okay, so visitor design pattern is kind of those pattern. There are other pattern also which I am going to cover in my future videos. Okay, so let's see the implementation. So in my IDE, I have both the implementations. So inside a macro of traditional way is a polymorphism way. Okay, so this code is kind of a cluttered, but I'm going to upload a source code of this in which I will just share the whole source code in a more structured way. But for the video sake, I have included in both the solution in the same file, so that's why they are inside a macro. Okay, so let's go over to the implementation and what's problem it is. Okay, so there's we have a shape. Okay, and the problem is like customer he wants to save, like we have a bunch of objects, circle, rectangles, cubes. Okay, they all are say shapes, and customer want to save them. So what traditional implementation is like, we implement a save pure virtual function in a base class shape, and then the drive class inherit from that shape base class and override that save function. Okay, and there is a dummy implementation, but there can be any implementation like right now you are saving in raster format, it can be any other format. Okay, same for the rectangle. So these are simple implementation which we are using as polymorphism as a tool to solve this problem. And then inside of main, I have I have created a vector of shapes: circle, rectangle, rectangle, circle. Okay, and then I have done a simple for generate loop, for range loop, sorry, and I called the save function of each objects. Okay, and it'll just do the right thing. Okay, sorry. So let's just try running this program. Okay, as you can see, the program ran correctly. So we saved the circle in raster format, and we saved the rectangle object in raster format, and we saved the circle object in a raster format. So this was a required functionality. But now a user wants, like, he want to save in particular raster format. So now user wants to change the implementation. We don't want to save in raster format. Now we want to save in some other X format. Okay. Now what I have to do is I have to go change here. Okay. And change here also. That is, I think, fine. So I'll just do that, and this is done quickly. But now as you can see, I have to change the objects. I have to change the data. Here circle, here rectangle. So in large application we don't want to touch data that frequently. If new requirements comes up, we don't want to alter the data. Okay, so in that case what we can do is we can use a visitor design pattern. Okay, so in visitor design pattern, let me just get rid of this thing and just copy paste here. Okay, so this is open. Now let's just make close this thing. Okay, old implementation. Okay, now let's see the visitor design pattern and how is it implemented. So first I have a shape like in previous example, and then we have a circle and rectangle. But now here we are not implementing the save function. Here we are implementing a accept. So generally visitors are implemented like this. So there is a accept function in the base class, which is a pure virtual function as you can see. And as a parameter, it is taking a uh, visitor class. Okay, so and these uh, shapes, circle and rectangle, will do the implementation of accept, which is below here. What they are basically doing is like they calling the visit function of visitor class with this. So here this is important because this is used to differentiate between the circle and rectangle object here. So I'll discuss the visitor class, then I'll show you the whole example how it's functioning. Same for the rectangle. I have accept function taking a visitor class and then calling the this. Then I have a visitor class which is a base class, and it is at two data types only, circle and rectangle, for which we want to do the implementation of that save. And then we have a save visitor because we are want to save the objects. So what I have to do is like I have to implement a visit function that is taking a circle pointer, and then I have to implement a visit that is taking a rectangle pointer. So now here we are passing a this will be circle, and this will be rectangle. So this will be detected at the runtime and it will be called appropriately. So if I run this example, you see the same output as seen in the polymorphism, as you can see. And now if I have to change the implementation, I just go here and then do the same thing, change to X, then recompile and then run. It's all good as you can see. But now as you can say, the effort is same in both the cases. But here we haven't modified the data. The circle and rectangle are intact. And I have a save visitor today, but in future I can have any number of visitors doing any other functionality without manipulating the circle and rectangle. Okay. Okay, so I'll just share the source code if you want to look at it. I can just pause the video if you don't understand something. And the flow of this is like this. So I have a visitor, okay, and I'll iterate over the shapes, which is same as the previous example, and I call accept function. So this visitor will be used here, and we call the visit, which will be this visit because we have this as a circle, okay, and due to this it will select this function and this line will run. Similarly, when I have a rectangle object, I'll come here, I pass the save visitor, it will be passed as a reference, and it will pass a reference to this function. And in this case, this is a rectangle, so it will select this candidate and it just execute this line. Okay, pure and simple. Okay, so as I told you that it is not applied every time you have same kind of problem. You can apply this problem only when you have general characteristics in your problem set. So first is like you have a bunch of objects, okay? They're different objects, and you want to do a operation, similar operation on all the objects, like this example, okay? So you can use a visitor. That's cool. And then second example I can think of is like you have some objects, you want to do a operation on all the objects, but some objects don't implement that functionality which you want to take. Okay, for example, I have an object tree. In that case, I have a declarative nodes, expression node, and statement nodes, and I want to do operation on statement nodes and expression nodes only. I don't want to do an operation on declarative nodes. Okay, so what I'll do is I'll just implement a visitor for my functionality, and I'll just implement a visit, and for declarative node I'll just put empty line, no up. I'll do nothing. And then for expression and statement nodes, I'll do the operation which I want to do. So in that case it will just run perfectly fine using this architecture. So here without without touching the data you have added the operation. Okay, and next I can think of like hmm, and next I can think of is like when some operations are more frequent, more prone to changes frequently. So like I have this function, this particular save thing, and right now we are saving in X format. In future you might have requirement to do Y format. So we don't want to touch data that frequently. We just change the implementation of the visitor and we will set to go without touching the data. So in this case, whoever using a circle and rectangle, they don't have to worry about the new functionality. Okay. And now one side effect which I want to mention is like if you want to of visitor design pattern, if you want to access the private members of these data, you can't directly because these are passed objects. So you have to have some kind of accessor function to that do that kind of operations. I am not able to find any um, solution to that problem, but there might be. Okay, so hope you like the video and please subscribe and like this video and share with your friends. And if you have some suggestion or questions, please do let me know in the comments. I'll try to answer them. Okay, thanks for watching. Bye.